FeatureCAM now has the ability to smooth the azimuth and elevation axes independently of each other using one of several smoothing options. One such option is the new stepped stabilization smoothing. This type of smoothing will stabilize or lock the rotary axis movement by maintaining a fixed tool axis as much as possible within an angular range. This toolpath will appear as a series of 3+2 axis segments with 5 axis transitions between them. The transitions can be either completed on surface or with a lift. In this example we have a trimming toolpath that we are making our way around this car door. We have a stock already set up, which in this case is a large STL file, and we're simply going to run a ball nose tool along the trimmed edge of the door. We have 3 features already pre-created. In this case we've got a traditional one with no smoothing, we have a trim toolpath that has the smoothing applied, and we also have a third toolpath which is the trim with the stepped smoothing on surface. If I uncheck the first two, I'm just going to play the machine simulation of the first operation. Here we can see as the part is being machined, the tool is making its way around the edge. We can see some rocking motion from the table as the tool makes its way around the part. Any sudden direction changes such as these are going to leave witness marks during our machining process. In some areas of the model it's impossible to avoid the rotation simply because we are making our way around the corners. However, it is areas such as here where we can see the machine rocking backwards and forwards, and here that we're going to try and avoid with some of our smoothing options. We have 2 examples. You can see we have the trim smoothed. In this case, under the 5-axis tab we have tool axis smoothing, and we've set the options to be smoothed with a maximum angular correction of 45 degrees. The third toolpath again is the same trimming toolpath, 5-axis with tool axis smoothing on, using a lead lean orientation. And in this case you can see we've got stepped on surface with a maximum angular correction of 80 degrees. The aim here will be trying to produce a toolpath that will appear more as 3+2 segments rather than a full simultaneous 5-axis. As highlighted before, there will be some areas where we get continuous motion, for example around the wheel arch. Let's play the simulation for the third toolpath. So again we have the inevitable corner as the tool rotates around the part, but now you can see the table is briefly fixed whilst we make our way along the straight edge, and then we rotate back to get towards that wheel arch area. Again, you'll note that the table is not moving. until we reach this corner area, where again we need to rotate around for access. So in this area you can see there's a lot less motion from the machine as we make our way around those edges.